So, good evening, everyone. I am Smita Das, primary research scholar from IIT Guwahati. Today, I am going to work on the current live session. We are basically doubt solving. We will solve the doubts related to the question of the course Medical Biomaterials, which is BT 44, and today is the first week. So we will solve basically the problems related to introduction of biomaterials and their mechanical and physical properties. So, mm, so here will be the first question. Select a non-biomaterial from the list. So please, can anyone tell me which will be the correct answer?
Thermometer.
Okay, anyone else? So there is the hand raise option is there. So it will be great if you who all the thinks the option the thermometer will be the correct option. So please raise your hand. And so am I able to clear that who all think that thermometer will be the correct option? So uh, I found only two, three people are raising. So okay. How many of are not agree with the answer thermometer? Is there anyone who is not agree with the answer thermometer? Okay, so now can you tell me what is the meaning of LVAD?
Left ventricular assisted device.
Okay, what is it? What is the purpose of using this material?
Like pacemaker and heart ventricular assistive device. So the classification is RVAD, LVAD, and VVAD. So basically for artificial heart and yeah, assistive device.
Or basically for supply the bloods, right? From heart to other organs. Is it somewhere correct? On your to your answer? Like,
Yeah, it's actually percutaneous device.
yeah. So what is the next Worth screw? Anyone tell me what is ortho screw and what is the use of ortho screw?
It's basically titanium made screw for artificial knee replacement.
But only the knee, or you can use screw in
Or
any else in
hip
any
joint
other part.
or hip joint or dental augmentation.
Okay, so what is the purpose? Like to join the parts, right?
Yes. Yes, madam.
Okay, so what is the third? That is the catheter.
Catheter is a tube kind of thing that is like implanted in the body to drain out fluids or something like that.
Sorry, can you repeat the answer again?
It is a tube-like substance that is implanted to drain out fluids from the body.
Okay. And what is thermometer and what is its use?
Thermometer
Anyone?
is
To measure the increased temperature, body temperature.
Okay. And why we not consider thermometer as a biomaterial? What is the definition of a biomaterial?
Biomaterial should be synthetic material, and thermometer is not synthetic material. And
Biomaterial always should be synthetic or certain natural material can be used as a biomaterial.
The
natural, yeah, yeah.
biomaterial stays along with the body, but this thermometer is just to measure the temperature and then we can remove it. Biomaterial will be staying with the body always.
Okay. So, so as per the definition, which is uh, already studied in the course, that is biomaterial is any substance. It can be natural or synthetic, used for something as complete or as a part in the human body system in order to treat, diagnose, or replace any tissue, organs, function of the body. So, uh, as you will get to know about this definition, so did you consider if I put one sensor inside the body to get like get to know about every uh, day about the uh, s- uh, concentration of urea in my blood or concentration of the creatinine in my blood if I insert a sensor into my body. So that can be considered as a biomaterial or not.
it
No,
can be considered like it is present inside the body, so
So
it should be biocompatible. So it can be considered as a biomaterial. Thermometer, we are using
okay,
it
so anyone,
externally.
yeah. So someone is not agreed with the answer. Like he, someone can
actually,
tell me who thinks it's not a.
it is. Yeah, it is actually used to measure. Actually, biomaterials which should have a certain, functions which support the body functions. This is just measure used for measuring the thing. So that's why I just told.
But biomaterials, as per the recent study, the biomaterials can be used for function or support as well as to diagnose the certain parameters like concentration, certain things, certain disease. So we can also include the sensor as a biomaterial. So now, whoever is not known what is LAVD, LAVD is basically left ventricular assist device. It is a device that helps pump blood from the lower chamber of your heart to the rest of your body. Arthro screw basically is a titanium or stainless screw that are used during the surgery of fractured bones. This serves as a support for internal fixation of bones. Consider it is a tube that is inserted into your bladder, allowing your urine to drain freely. Thermometer is an instrument for measuring the temperature of any system. So, can anyone tell me how many types of ortho screw are present? Like as a general question.
Hello, is anyone
Hello?
speaking?
Yes? Hello?
Yeah, ma'am, we do not know the answer, I guess.
Okay, so basically one is the tips are very thin and the thread are used very smooth. Another one is the coarse one, and it's the thread which is used basically the coarse one, as per my knowledge. So now moving to the next question. So which one is not used as a dental biomaterial?
PLA, PLA.
Okay, anyone else?
Amalgam.
Okay. Any other answer?
Cement.
PLA.
PLA only, I guess.
I have one suggestion, madam. Hello. Hello. Hello.
Hello?
Yeah. Am I
Hello?
audible? Can you hear me?
Yes?
Hello. Yes, madam. For this question, that which one is not a dental biomaterials? Actually, in the question, you should mention the cement or dental cement, because as a whole, cement is different, which has a cementing nature, and dental cement is different. And in 1980, the first generation of biomaterials where PLA is used as a dental biomaterials, though it is a polymer
Yes?
biomaterial. Nowadays, it's not used.
Yes.
Nowadays, PLA is not used because it's soft in nature. And cement is basically some kind of means construction based that cement and the zirconia based. But dental
Yes.
cement is different, na? So question should be like dental cement and another options, option A, B, C, D, like that.
I am very sorry, but this question is not set by me. It is coming in the previous year question papers.
But
So I
as a
am following the question paper, that one. And
it is the right answer, because PLA first generation biomaterials 1980 first generation biomaterials PLA polymer, though it is polymer. Nowadays in fourth generation it's not used because of soft nature and mechanical properties. But cement it should be mentioned yeah, dental cement or biomaterials.
okay, so can you just tell me the what is the use of the dental cement? That one I want to ask. Like basically that is the main asking the
Basically
question. What we are mainly use this dental cement?
for filling dental filling or any filler like hydroxyapatite base or normal dental cement for filling as filling material.
It's basically used for a temporary restoration of the teeth or cavity lining. basically. And next one, what is the use of amalgam? Any idea?
It's used to fill
Amalgam,
cavities caused by tooth decay or something like that.
amalgam is basically alloy, madam. Is it alloy?
It is basically a mixture of liquid mercury and metal alloy.
Alloy, yes.
Yes. So what it is also used in the dentistry. So dental amalgam basically used for filling the cavities majorly. Titanium one. So if anyone want to write down, I'm telling dental amalgam is produced by mixing liquid mercury with an alloy made of silver, tin, and copper solid particles. Okay, and this composition of are controlled by the ISO standard, which is ISO 1559, and it's basically used for filling the dental cavity. And titanium.
Madam, why mercury is used with amalgam, madam? Because mercury is carcinogenic.
Yeah, mercury is carcinogenic, but it's a very small amount it is used. So amalgam basically any alloy where mercury is used. That is known as amalgam only. Otherwise, it is known as alloy. When we used mercury at a certain quantity in the solution, then it is known as amalgam. And it is already used. Like it is usually used for
Uh,
filling the courses.
for, for to make the material as hydrophobic or hydrophilic, for this reason, means copper in mercury is used, or the reason is something different.
No, it is, I guess, if when you find a cavity in your core area, to like it's as a very hard material and it is liquefied. So during that time, to feel to increase the strength of the teeth, it is usually used. So what is, can you tell me what is the use of titanium? So anyone understand the what is the why we use amalgam, or anyone
Structural
have any
application,
doubt?
titanium for structural application, ma'am.
A
Uh,
okay, okay, we'll go to titanium first. Anyone have any doubt in amalgam? So everyone understood what is the usage of amalgam? Okay. So titanium is basically used to give support to the your teeth. Like some like usually titanium are very lightweight, but also it is uh, has a good compatibility with the bones. So titanium is basically used to provide support to the dental system, to the teeth. It is used where bone would be directly contacted with your biomaterial. In that places, titanium is used. And the correct option is PLA. Now moving to the next question. Okay, so the dental implant is a prosthesis that interfaces with the bone of the jaw or skull to support the dental prosthesis such as crown, bridge, dentures, or facial prosthesis. So where in the first case it's the titanium screw, so it is basically used where it has a direct contact with your jaw bones. That this is titanium is used. Whereas in the crown part is mostly the cement or dental cement, zirconia cements are mostly used. And in the amalgam that is used basically to fill the cavities. Okay? Uh, should I move to the next question? Hello? Actually, it will be great if some like you have all the people that should interact. Otherwise, because it's an interactive session, so it will be great if you all are interact.
Yes.
Okay. What is the largest biomaterial market based on application? It is basically a factual question. So, it,
Cardiovascular.
okay. Anyone else?
Cardiovascular.
Anyone else? Okay, so the correct answer is
Cardiovascular.
cardiovascular. Now moving to the next question.
Is the screen visible to everyone?
No, no, it's not.
So the correct answer is cardiovascular. Based on the application, the market is usually categorized into uh, like one is cardiovascular, orthopedic, dental, plastic surgery, wound healing, tissue engineering, ophthalmology, neurologicals, and other application. And cardiovascular segment is considered as the largest share of the biomaterials. So the what is the pH of blood
7.4.
and how the
7.4.
blood of the pH is regulated? Anyone idea?
Bicarbonate ions and other ions in the blood.
Know which organ has a role to maintain the uh, plays a major role in maintaining the pH. So basically, our body maintains pH at by acid-base balance, and it is regulated by basically two organs. One is lung and another one is kidney. So, can anyone tell me how lung or kidney help to maintain the pH of the blood?
Is it by bicarbonate ion concentration? Like blood is a buffer, right? So in
Yeah,
lungs, the carbon dioxide exchange happens through that way. Can it? I guess it can uh, regulate the pH.
the pH of the blood plasma is basically depend on three things. First one is CO2, second one is electrolyte, and third one is weak acid concentration. And lung help to gasian exchange and remove of the CO2. And during this process, when the blood pH has fall or rise, it will based on that our exhalation and inhalation process will occur. And apart from that, kidneys also play a major role, which maintain the pH balance through the excretion process. And what is the condition if our pH is imbalances? If pH is higher than as per your uh, knowledge, the correct answer is the pH of the blood should be between 7.35 to 7.45. So if the pH of the blood will be more, then the condition is known as if the pH is more than 7.45, the situation is known as alkosis, and if the pH of the blood is less than 7.2, that is known as acidosis. So the it basically indicates the alkalinity and the acidity of the body, and it is an indicator of the good health. So as I mentioned, the pH of the blood plasma depends on the three things. First one is the CO2, electrolyte, and weak acid concentration. The high blood pH, that is the alkalosis, is happen due to the following reason. First one is the excessive loss of fluid, such as excessive urination, vomiting, diarrhea, and when kidney do not able to remove excessive alkaline substance from the blood. And acidosis, the acidic blood condition, when the blood pH is 7.35 or basically less than 7.35. And it's happened because of the two reasons. One is the kidney disease or kidney failure, or lung disease such as pneumonia, bronchitis, asthma, chronic or pulmonary diseases. Now moving to the next question. What is the normal core body temperature?
37 degrees.
37.
So why 37 degrees maintained? Because it at one side it is warm enough to prevent the fungal infection, and also it help we can maintain a certain temperature. For that we should not eat as a random basis to maintain our metabolism. Okay, so dental implants are not made of a similar type of question. So can you tell me what is this SS316? TY you know, amalgam you know, and what is SS316 and PMMA?
Stainless steel.
Yeah,
Stainless
just
steel with carbon percentage 0.08 and SS316L, that is carbon percentage 0.0.
okay. Thank you for the information. So basically, uh, here the correct. What is the correct answer here?
PMMA.
PMMA is the correct answer. Now moving to the next question. if the strain, someone asking for the numerical question, so it will be a numerical question. If the strain of a polymer piece which is extended by a force is 0.015 and if its original length is 5 centimeter, then what is the increase in its length in mm? I encourage all of you to solve this question and tell me the answer.
Zero point 0.75.
Okay, and apart from that, okay. And how many of you get the answer 0.75? Please raise your hand. I give another 5 minutes who are not able to solve the question because only 6 people raise their hand, I guess. 5 people raise their hand, so I give another 5 minutes. So who all are not able to solve, please kindly tell me. I solve it and tell me the answer. So what is the mean by uh, strain? Can anyone tell me what is the meaning of strain?
Engine length
Uh,
by
that's
original.
for del L by L.
Mathematically.
Del L by L.
Hello.
Yeah, yeah, yes. Del L by L, madam.
Del L by L. Okay. Uh, so anyone else have any different thought about? Okay. So the correct answer is uh, So the original length, as per the definition, is considered as a 5 centimeter as per the question, and extension by force or strain can be del L by L, that is 0.015. So increase in the length will be 0.015 into 50 mm. So everyone understood why it is comes as 50?
Original length in centimeter, so it in millimeter, I think.
Yeah, the correct answer is the your the question here is original length is given as a 5 centimeter. So 5 centimeter is equal to 50 millimeter, and so for there we can get it the 0.75 mm. So I am also giving a question in the similar type of question in the chat box. So I encouraged all you to solve the question and tell me the correct answer.
Ma'am, one request, can you please share your PPT, madam?
Yeah, PPT will be uploaded in in your course page, I guess. It will be done by the NPTEL. So they will
No,
share the PPT. Sorry?
what shared by the NPTEL authority is full course material, and
No,
your
no,
is
no. There will be a separate section for the doubt solving session. So in that section, you will get the YouTube link of this video as well as the question paper, the PPTs.
okay.
As per my knowledge. So if
Okay,
you're not there, you will can tell me in the upcoming classes. I will share it with you.
sure, sure. Thank you.
Okay, so I am share the question uh, in the chat box. So I request everyone to solve it in just a minute. Okay, I shared the question in the chat box. Please solve the question and tell me the correct answer. So after solving the question, whoever will get the correct answer, please raise your hand. Don't say the answer here. I'll ask you. Okay? And please, whoever raised their hands, please whoever has just solved the question, please raise the hand. Please do not raise your hand or leave your raise option. Okay, so I'll ask in another 2 minutes. I'll give another 2 minutes. Please solve the question who are not able to solve till now, and then I'll ask the answer. Okay, so I asked not to share the answer, but already shared. So, Anish Parida. So, can you tell me what is the correct answer and how would you able to solve it? Hello, 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 hello. I would request everyone not to share the answer. I will ask one person, then that person will share the answer. Otherwise, we'll keep the answer with you. I will tell the correct answer and how to solve the procedure. Okay. So, uh, Daisy, is she available right now? Daisy,
Yeah. 0.045 meter.
0.045 meter.
Yeah.
Okay, and on how much in the millimeter?
1 minute.
Okay. So, Kajal Jain, what will be the correct answer? Like, what is your answer?
Ma'am, in meters it is 0.0045 and in millimeter it is 0.45.
Yeah. So the correct answer is 0.45 millimeter or 0.0045 meter. So here, the as the question suggested that L divided by del L. This is equals to 0.015 divided by 100. Okay. So am I correct? The L by dl equals to L by delta L equals to 0.015 divided by 100. Has anyone have any doubt in this part? Has anyone have any doubt in this part? Okay. So the
No.
next part is here just multiplied with 3. So the correct answer is come as 0.0. Please don't take the control of the presentation. Uh, Otherwise, it will be difficult for me to help. Okay. So the correct answer is 0.45. 0.45 into 10 to the power minus 3 meter, which is comes as 0.45 millimeter. Okay. So the next question, please all of you uh, put down your hands. I request everyone to put down their hands. Okay, so who all get the correct who all able to solve the next question which they shared in that group? Anyone started the next question? Attempted the next question? Find the strain of the steel rod of length of 250 millimeter which is subjected to tensile load of 15 kilonewton when the extension of the rod is equal to 0.3 millimeter. Okay, only one person able to solve. I give another 5 minutes. Please solve this question. This is an easier one compared to the last one. So I request everyone to solve. Whoever not able to solve till now the last two question, I requested to please try to solve this question. Okay. So only four people till now able to solve the question. Uh, Okay, so Ramya R, can you tell me what is the correct answer? Ramya R, Ramya R, are you present? Soumya, hello, Soumya, hello.
0.0012.
Okay, and how did you solve it?
Strain is equal to extension by the original length. So extension is 0.3 millimeter and the original length is 250 millimeter. So 0.3 by 250 is 0.0012.
Yeah, correct one. So the strain equals to, as I mentioned here, the okay. So extension by force or strain equals to del L by L. So here del L as per the question is mentioned as 0.3. See, and your L as per the question is mentioned as 250. 50. So DL DL by L equals to 0.3 divided by 250. Okay. So the answer is comma 0.012. I put the next and please all of you now remove your hand. Okay, I put the next question in the group uh, in the chat box. All of you are requested to solve it and tell me the answer. Okay, I'll try start to solve this question, the given question in another 10 minutes. I will request to try everyone and find certain values to help to solve the question. Okay. So, uh, Kirtana. Okay. Kirtana Ramaya. Okay. So, Ramaya, who
Yeah,
are
ma'am.
able to solve this question?
Hello.
Hello.
Yeah,
I'm
ma'am.
asking, are you able to solve the previous question?
Yes, ma'am.
Okay. So, what is your answer?
I got it as 0.40833 into 10 to the power of minus 6.
Okay. And anyone else? Ramaya. Ramaya.
Hi, ma'am.
Can you, yeah. Can you tell me the answer?
Ma'am, actually, I'm reworking it. First, I had to convert this gram to Newton, right, ma'am? 500 gram.
Yes. Yes.
I, what I did is I just put gram and I solved it. So it was wrong, and I'm reworking it, right?
Okay.
So, so 1 gram is equal to 0.01 Newton. Is it? Am I right?
No. Oh, yeah. Sorry. 1 gram equals to. You're supposed to
Point
convert the kg weight into dyne per cm, like in dyne.
dyne.
Yeah.
So
Because
gram to
your
dyne, we have
mod
to convert.
half kg weight is right, kilogram weight.
Yeah.
Okay, so half kg weight you're supposed to convert it into dyne.
Okay.
Okay.
So one gram
Otherwise,
is one
okay,
gram is
I'll solve
equals
it.
one
Okay.
dyne, right?
Sorry?
1 gram is one dyne.
Yeah.
So 1 gram is one dyne means it's a 500 dyne. So the stress is 318.18
Okay, Ramya, I'll
dyne per.
solve it. You just check, okay? I'm going to
Okay.
solve it. Just check. Yeah.
Okay. Okay. Good.
So first, as per the question, the diameter of the wire is okay. So the first one is D. D equals to given as. Please write down the steps because I may remove after certain time because there are less empty space is there. So first, this is 1 mm, right? So 1 mm is 0.1.
Ma'am, nothing is visible. Are you writing it on the slides?
Yes, is coming.
I don't know
No,
why
ma'am,
is it not
not
visible.
visible.
Okay, just a minute. And, at room view and your view. Blank. Can you tell me from where you can get this blank sheet? Like that is a breakout room. Gallery towards phone. Exit content only private information. Slide is also visible or slide is not visible? Hello?
Seventh question is
Slide
visible,
is
ma'am.
visible. Slide is
Okay. A minute. The previous question that solution which I solved it visible or not?
It wasn't visible, ma'am.
Okay. A minute. Please try to solve the next question. I'll give the solution in 2 minutes. Okay?
Ma'am, your voice is not clearly audible.
Please try to solve the next question. I will I will show the answer in 2 minutes. I already gave another question in that chat box. Please try to solve it. I will show the solving part in 2 minutes. Hello, is the slide still visible?
Yes.
Yeah. So, as per the question, the diameter of the wire is given as 1 millimeter, or we can convert it as per our convenience to in centimeter, that is 0.1 centimeter. Now, moving to the next question, the force is mentioned as half kg weight, right? So, half we know the weight can be also calculate. Weight is considered as a force as a law of the physics. So half kg weight can be also converted in means the half kg, that is the mass of the material, and weight means the gravity, that is come as 980 when it comes to the CGS scale. So half into 1000 into 980. So that is the force applied. Now, as per the question, the Young modulus is given as 12 into 10 to the power 11 dyne per semi square. So there is an philosophy, that is Young modulus, basically the force. There are several tensile modulus, Young modulus. There are separate types of modulus. It basically means force divided by the area. So force by area. So that can be also written as stress. So stress is also equals to strain. So stress del L by L is equal to 4F by pi d square y. So from there that we solve it and we get the correct answer is come as 0.052. Okay, so able to understand the solve or have any doubt, please tell me. If anyone not able to understand in certain steps, please let me know. Hmm. So today I assume that all of you understand this question. Does anyone have any doubts? Okay. So has anyone any doubt?
No.
Yes. Sakshi Goshavi, are you there? Are all you able to understand the question and answer of the answer of the question? How to solve this type of problem? Is clear to everyone?
Yes.
Okay. So I also mentioned one more question in the chat box. Please solve it and tell me the answer. Ramya, can you please put down your hand? Yeah. So please solve this question and tell me who will get the correct, like whatever answer you get. Please let me know. Hello. Hello. How many of you able to solve the first part, the stress calculation? Please raise your hand. The first A part, the calculation, the stress one. Part B. Anyone able to solve the part B? Okay. So Ramya, can you tell me how do you solve the part stress?
So stress is it 318.18 Newton per millimeter square?
Yeah. So how?
So
Yeah.
force by
Keep on.
area,
No, no, no. I'm
100 kilo
asking
Newton.
how do you solve it? Yeah.
So the force by area is a formula. So 100
Yeah.
kilo Newton is given. So 100 into 1000 in the top, and pi
Yeah.
r square. Here it is 10 mm is the dia.
Yeah.
So its radius is given 10 mm. So
Yeah.
22 divided by 7 into 10 into 10. So when you solve it, you'll get around 7,000 by 22. It's around 318.18 Newton per millimeter square. Is it right?
Okay, but you supposed to be the answer should be in Newton per meter square.
Meter square you have to convert.
Yes.
Okay. Um, so what you have to do is again you have to divide it by 1000, right?
Yes.
So it will be 0.318
Yes.
Newton per meter square. The
Ye-
elongation young modulus is given.
Yes.
So actually I converted that into millimeter square. So I didn't convert the stress into meter square.
Okay, so please
I
do the convert everything in the meter square and recalculate the because your calculation for stress is correct, but your elongation is not correct.
elongation actually it is 159.09 into 10 power minus 8 is this strain,
Yeah,
and the
that
change in length is 0.00159 millimeter.
not 0.00159 millimeter. You get the some mistakes in there in the your conversion. You check the conversion
Okay.
because
Okay,
the
I'll do.
values are correct, but you have certain mistake in the conversion. Please check it. And Daisy, do you able to solve the questions?
Yes, ma'am.
So how calculate the elongation?
Elongation y is equal to stress by strain. So now the
Yeah.
stress will be 3.18 into 10 to the power 8
Okay.
Newton, and the strain will be strain formula del L by L. And here, if we rearrange, finally we'll get it as del L is equal to 3.18 into 10 to the power 8 by y. So length is 1 actually. So we can
Okay.
move this del L left this side, and finally if we calculate it will be 0.00159
0.00159.
meter.
Okay, and in if you
Oh
convert
no
in
no oh
millimeter,
no yeah millimeter. Okay, I have to convert, right? So it will be in meter, right? Del L.
no, I am asking the del N in millimeter.
Yeah, if it is.
You tell me the answer in meter, but I am asking you the
You
answer
have
in
to divide.
millimeter.
Yeah, you have to divide by 1000.
To conversion of millimeter meter to millimeter, you have to multiply it with
Mul-
1000.
yes, okay.
Okay, so it should become around 1.59.
Okay.
So anyone and how do you calculate the strain? The percentage of the strain?
Yeah, strain, yeah, del L by L into 100.
Okay, so it comes around?
0.159%.
Yes. So the correct answer is that. So I am going
Ma'am,
to
I
show
have
the
one question, ma'am. Actually,
yes,
in calculating stress, we are using force per area. Actually, we have to use that area as pi r square, right?
yes,
Yeah. Yeah. Okay, ma'am. Yeah, because it is raw, I used pi r square. Is it correct only, ma'am?
yes.
Okay.
So here is the solution. That is R equals to given as 10 mm. So we converted it into meter. That is 10 into 10 to the power minus 3 meter. Which is also can be we say 10 to the power minus 2 meter. Now length is given as 1 meter. Force is given as 100 kilonewton. So if we convert it, it comes as 10 to the power 5 Newton. The stress, the Young modulus is given as 2 into 10 to the power 11 Newton per meter square. So now the stress is force by area. For is area as we considered in a particular area, not for the whole where. So it's basically the circle which we are going to consider. So F by pi r square. So F 10 to the power 5 divided by pi into the square of the radius, which is come as 3.18 into 10 to the power 8 Newton per meter square. So next the elongation that is del L by L equals to F by A. Y equals to F by A equals to del L by L. So if we rearrange it, the del L is comes as F by A into L divided by Y. So from there we can calculate it is as 1.59 millimeter. The strain is comes as del L by L, which is also can be calculated 1.59 10 to the power minus 3, and the percentage of strain in the rod that is comes as 1.59 to 10 to the power minus 3 into 100, that is 0.159 or approximately 0.16%. So now that is for the question. I hope all of you understand the numericals. Some of you have a doubt regarding the numericals, so I hope some doubts may be cleared. So now move to the last part, the question number 8. The bioactive materials are in generation implants. Which generation implants?
Second generation.
Okay, and how the generations are classified for the like which all materials are getting in which generation?
First generation it is bioinertness. Second generation is bioactive and bioceramics and polymers. Third is regenerative tissues and nanocomposites. And fourth generation is tissue engineering and scaffolds.
Yeah. So the first generation, the biomaterials are usually classified in four generations. First generation is the bio-inert materials, which considered basically the metals and sorry, yeah, which considered the metals. The second generation is the bioactive materials or bioresorbables, which completely dissolve in the system. The third generation is The third generation is a nanocomposite materials, which is also involving the bioactive material. And the fourth generation is the biomimetic material, which is basically the scaffold and the tissue engineering products. So, as per the question, the bioactive materials comes as a second generation. Which polymer has oxygen present in its structure?
Polyvinyl acetate. PVA.
Oh,
PVA.
okay. So, can you tell me what is the full form of PTFE
Polytetrafluoroethylene.
and what is the monomer of this polymer? Like how?
Tetrafluoroethylene.
Tetrafluoroethylene. Correct. PVA. What is the full form of PVA?
Polyvinyl acetate.
Okay, and what is the formula of its monomer? It is
Two
C2H4.
acidic groups linked to two carbons, like vinyl
Uh,
position of carbons.
so it is C2H4O well N. The monomer is C2H4O. So what is PP
Polypropylene.
and what is the monomer of this?
Pro, propene.
Propene.
Propi, propene.
Propene. Propene. Now PVC
Polyvinyl chloride.
and what is that? Uh,
Monomer. Vinyl chloride.
yeah. So the correct answer is polyvinyl alcohol. So here is the structure of all the monomer. If anyone want to take a take a please write down it. Now next to the next question, the fracture toughness of a biomaterial is what is known?
Crack propagation.
Why?
So, the propagation of the crack will tell like how tough the material is based.
It's basically the correct answer is the crack propagation is basically quantify uh, the is how the crack will propagate, and it also defines the uh, material tolerance for pre-existing cracks and other stress concentrating features. The correct answer is the crack propagation. Uh, It is basically helpful to evaluate the serviceability, performance, long-term clinical success of the biomaterial. It is reported that the high fracture toughness material improve the chemical performance compared to the low fracture toughness. So it's basically help to quantify the tolerance of the material, how they can withstand the cracks which is already pre-existed in the material. So okay. So have anyone have is anyone have any doubt in any question? Does anyone have any doubt? Okay. So with this, I will conclude today's session and hope to meet you in the next session. Thank you.
Thank you.